Okay guys, what we're going to have a look at here is using information that the examiner supplies you with to allow you to work out what type of structure and bonding there is within a particular substance. So you should know by now, if you've gone through all the videos and the notes etc., that different structures and different types of bonding have different properties. Essentially we're talking here about melting point, boiling point, ability to conduct as a solid, ability to conduct in an aqueous solution, ability to conduct as a liquid. So if you're not 100% familiar with those, these questions will prove really quite difficult for you. So if we have a look at the first one, I'm assuming that you do know all of the types of structures and their properties associated. Okay, so we've got A, B, C and D here. Okay, we've been giving melting point, we've been giving electrical conductivity as a solid and electrical conductivity of liquid. So you should know that things with high melting point are giant structures. Okay, you should know that things that conduct as a solid would be only metals or perhaps graphite and non-metals. And you should know that things that do not conduct as a solid but do conduct as a liquid are ionic, because here the ions are free to move, whereas as a solid the ions are not free to move, they are in those fixed positions. So we will go through this, we'll have a look at each one individually and we'll try and work out what the structure is. So we'll just write S here and what the bonding is. Okay, so we'll just fold that over. Okay, so here we have S and B. So for our structure on our bonding, right, okay. So let's look at this first one here. The melting point is reasonably high. Okay, it's certainly higher than you'd expect for simple. Okay, so we can say pretty much that the structure is giant. Okay, and so this is for A. Okay, just ignore that. And the bonding, well, it's conducts as a solid. Okay, the only one that we know that conducts as a solid is either graphite, which you should know has a huge melting point of well over 3000. So it's not graphite, so it must be a metal. Okay, it must be metallic bonding. If we look then at secondly at B, okay, again high melting point. Okay, does it conduct as a solid? No, it does, so it must be giant, so we'll just put down giant. Does it conduct as a solid? No, so that rules out a metal. Does it conduct as a liquid? Yes, it does, so therefore it must be ionic. It's got free ions at that stage. C, really high melting point, so I'm probably thinking giant, certainly. I'm probably thinking, because it's so high, it's giant covalent. Does it conduct as a solid? No. Does it conduct as a liquid? No, must be covalent. Really low melting point here. Okay, so 44, so that tells me that the structure there is simple. Okay, and does it conduct as a solid? No. Does it conduct as a liquid? No. It's covalent. So those are your 4 different structures and bonding. 3 giants, 1 simple, 1 metallic, 1 ionic, 2 covalent. So going back to the question then, which substance A, B, C, D could be zinc? Well, zinc is a metal, so therefore A must be the answer. Which of the substance A, B and C, D has simple molecular? Well, there is only one simple one. Got to be D. Which type of bonding is present in C? It is giant, but the type of bonding is covalent. Okay, and final question then, which of the substances A, B, C, D is likely to be sodium chloride? Well, sodium chloride is ionic, metal and non-metal, so that's got to be B. Okay, so hopefully you're able to follow that. I'm going to put a few more of these up, guys. If you just really read through the question, or if there is no question, you're just looking to assign structure and bonding to them. And okay, so here's another one. we've been giving melting points, boiling points, electrical conductivity as solid, and electrical conductivity as liquid. So we'll go through them again in exactly the same way as we did with the last one. We'll, first of all, before we even do these questions, we will assign whether they are giant or simple. So if you have a look at them there, okay. So let's go through. Let's look at A first of all. Its melting point is extremely low, as is its boiling point. We're talking right away down below 0. Okay. We have electrical conductivity is very poor in both solid and liquid. So therefore, it's certainly not giant. It must be simple. So we'll just write simple, and its bonding must be covalent. Okay, let's look at the next one. We've got very high melting and boiling points here, so when thinking structure is giant. Does it conduct as a solid? Yes, indeed it does. So it must be either metal or graphite. Well, it's not graphite because graphite melts at over 3000, so it must be metallic. This one here has got an extremely high melting and boiling point, so it's definitely giant. Okay, very poor conductor, very poor conductor. Well, that tells me it's covalent. It could have been graphite, but it's not because of the conductivity. I'm guessing it's diamond. Melting point here very, very low, so I'm thinking simple, can't conduct, simple covalent. Highish melting point, highest boiling point, poor conductor as a solid, good conductor though as a liquid, so it must be ionic, so it's giant ionic. So that's what you've got to do with these, is go through them first of all, work out what structures and the bonding is, and then do the questions. So, which of the substances A, B, C, D could be diamond? Well, diamond is giant covalent. There is only one of them is giant covalent. That's C. Explain your answer. Well, you just talk about an ability to conduct when molten and when solid, and a very high melting and boiling point, meaning that it must be giant. What substances are made of oppositely charged ions? Well, that's got to be an ionic substance. So therefore the answer to that is E. There's only one giant substance. Which substance contains covalent bonds between the atoms? Okay, well, between the atoms, covalent bonds between the atoms, we've got simple covalent here, we have a giant covalent here, and we have a simple covalent here. So we have A, C and D. So the answer to that one, I'll just pop it up here, is A, C and D. Note the question is which substances have covalent bond between the atoms and van der Waals forces between the molecules. Well, that means it must be simple. So that's A and D. Okay, so hopefully you're starting to get these. We'll put another couple up. I just want you to work out the structure and the bonding of these based on the information that has been given to us in the question. Okay, so there's our information again. We've got melting, boiling, okay, and conductivity. So I will just put these in. If you want to pause the video, guys, and have a think about this, looking at the information, and then come back in a few seconds and check them, what I will do is I will just simply write the answers in down below, and then you can come and check. So. Okay, so first of all, A has got a very high melting and boiling point, so it's giant. It's a good conductor as a solid, not as good conductor as a solid, and a poor conductor as a liquid. So that is giant covalent. Okay, B is probably graphite. B is very, very low boiling point and melting point, so that is simple. It is a covalent because it doesn't conduct either way. C is relatively high-ish melting and boiling point, good conductor as a solid and as a liquid, so that is giant and it is metallic. D has got a very high melting and boiling point and is a poor conductor across the board, so I think that is certainly giant and it is covalent for D. And E has got a highish melting, highish boiling point, doesn't conduct well as solid but does conduct as a liquid, so it is giant but it is ionic. Okay, right, the last one then, and again I'll let you have a look at it and take a few seconds to make, or a few minutes if you want, to make your mind up. All we've been given this time is melting and boiling points, so we will do structure and bonding again, so I'll leave that on there. You go away, do your working out and then come back and tell me, or check your answers, sorry. Okay, so chlorine then, which is the first one. Okay, so we'll just write S and B for structure and bonding. Okay, so the first one, which is chlorine, really low melting point, so it's simple and its bonding is covalent. Okay, zinc, okay, is giant. Sodium chloride, high melting point, is giant. Very high melting point again is giant. Diamond is giant. Okay, zinc you should know is pure metal, so its bonding is metallic. Sodium chloride you should know is a metal and a non-metal, so its bonding is ion. Sorry, we can't tell the bonding from the information in the question. You should be able to work out the bonding in these. Quartz is silicon dioxide, which is not on the new syllabus actually, but silicon dioxide is a non-metal, so again that's covalent. And the last one is diamond, and you should know and recognize diamond as being giant covalent. So if we just, so that it's clear for you, that's chlorine, that's zinc, the ionic one is sodium chloride, NaCl, the covalent one is quartz, and the covalent one at the end there, the giant covalent one, is diamond. Okay, so that is your final answer. Okay, so you would have been able from this information here to work out just the structure but not the bonding. Okay, but you should have been able to take the names and use that to work out whether it was covalent, etc. Okay guys, so I hope you're able to solve those little problems now. They may well crop up, so good luck.